So for company A, how would I write? So what is the unknown?
Televisions.
Number of televisions. Is that the only unknown?
Yep. I know you gotta figure out how many you need to sell for them to be equal options.
True, that's what we got to do. But that is the only unknown. The
Right.
number of televisions. So what do you want to call it?
X.
X. That's crazy. All right. So can you write how much money she would make at company A?
1,700 or 17,000.
17,000. No matter what she does, she just sits on her ass. She got 17,000 bucks.
Plus.
Plus
100.
$100. Just $100.
Commission.
Times X.
Yeah, times X.
So almost anytime you see like a per phrase in an English sentence, so there would be a per TV. That's going to have a variable on it. 100 per TV.
More for
Now here's the other variable. This is the other variable. What does this represent? What we just wrote. What idea does this represent? Per what? Salary, yeah. So I'm going to call this shit S. So what would the salary be at company B?
29,000
$29,000. Look at that shit.
plus
Yeah, buddy.
plus
She could sit her ass and make $29,000.
plus 20x.
Now, real quick. If you were gonna sell, if you knew you were gonna sell a ton of TVs, like a lot of TVs, which one would maybe work out better in the long run?
Company B.
Company A.
Yeah, company.
Because you're getting $80 more per TV. So if you're gonna sell a ton of TVs, this one pays you for that, right?
You sold 10 TVs.
Rewards you for that.
That's $1,000.
If you're not gonna, if you're like, I suck at selling, couldn't sell a bottle of water to a dude in the desert, right? Come on. Oh, I'm okay. I'm just gonna- then you want to do this one, because this is the one that gives you money and then just a little bit for every TV. So what this is asking is, where exactly is that line? How many TVs would you have to sell for these two to be equal? Now, really, I'm going to make you look at this more than you really have to. What form are these in? No. All right, not form of solving, but each one of these. X plus
Yeah.
Yeah, mx plus b.
Yeah.
So doesn't this one start higher?
Yeah.
The y-intercept is 29,000, but why is he going to catch up? Because his slope is much bigger. So that's why it kind of makes sense that they will meet somewhere. Sure, he starts off at a higher rate, but this is going to eventually catch up. So really what we're asking is, how many TVs until that catches this?
Or intercepts.
Yeah, and that's what catches means, right? I like it. So how the shit do I do that? So this is kind of funny. This is the most direct substitution. What is S? This. And it's this. So these two have to, in fact, isn't that the idea?
Yeah.
I didn't even need this, to be honest. I just put it up there to make there be two variables, so it kind of like went along with the idea. But I just want those two salaries to be equal. So of course I take this expression for the salary here and equal it. And then you solve for X, and you see how many TVs. Is that cool, whoever asked that question?
What do you mean you equal it?
So take this
Yeah.
and equal it to this.
Oh, okay.
Yeah, 29, blah, 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 right? And then you're really, a couple steps, you're done. So there are things that happen like this all the time. I used to live in North Park, and there was a fitness center, and you could pay so much, like $300 down, and then you have to pay like $10 a month. Or $200 down, then you have to pay like $20 a month. So of course, I'm a math geek. I think you picked up on that. So I kind of figured out how long I thought I was going to live there to see which one made the more sense to choose, right? If I'm going to live there not very long, I'm going to choose the one with the less, the $200. Anyway, so this happens a lot in life. We have to choose between some things. And this is the way you officially do it. Are you guys with me? So this won't be that hard to do, because now it's just a regular old equation. This salary equals that salary. Solve for x. Is that all right? You guys look shell shocked, but nobody's asking.
Show us, like,
Well, no, I'm not gonna. So this is just solving.
So once you solve for x,
That's it. That's what's it asking for. They left the word many out, but how televisions? But how many televisions would you need to sell? And what's X represent? Number of TVs. So once you get X, you're done. It doesn't say anything about what her salary would be, right? She would be curious, but this just wants to know how many TVs she's got to sell. Okay. Maybe. Okay. So in general, if I said solve this system of equations, you would just take that equal to that. And that is substitution method, because what's y? Y is this. Let me put that there. Isn't that what we did up here? So it's just taking these and making them equal to each other. Okay. Anything else from homework stuff, or?
2017.
Okay. Measure of one of the small angles of a right triangle is 45 less than twice the measure of the other. Okay. Real quick, just to check everybody's geometry on. Right triangle, one of the angles is 90. Will the other two angles, how will they be compared to 90? Well, they have to add a 90. So each one of them is smaller than 90.
They're 45.
So what are the names? What do you want to call the two angles? We got sure. We got angle A and angle B. And what's got to be true? You already just told me. What equation? Is everybody cool with that? Right triangle, one angle's 90. A total triangle's angles adds up to 180. There's a much better way to say that sentence, but do that. Now I can bring in this other thing. The measure of one of them is 45 less than twice the other one.
X equals 2y minus 45.
So we're going to do A equals 2b minus 45. And of course, what method is that just screaming out for? So hopefully this is the substitution section. That would make sense. Okay. You guys see that? Is that all right? Was it the geometry part of it that was a little freaky? Maybe we forgot what that's supposed to be. I don't know. Whoever asked that, you can just.
No, I get it.
Okay. Anything else from homework or anything?
I made them equal to 160.
Oh, neat.
All the angles.
I like it.
It kind of gave me.
Well, it's okay. Yes. No. So there are, if you're looking at the book, and maybe some of the questions say this, but if two lines meet, so there's one solution to a system of equations, they're called consistent. If they don't meet, that's inconsistent. And if they're actually the same line, it's called dependent. I don't care so much about the names. Real quick, the reason it's called dependent, if I had y equals 4x plus 2, and I had 2y equals 8x plus 4, are those the same line?
Yeah.
Isn't that one just twice that one? So doesn't that one depend on that one? Because it's twice that one. That's why we call it dependent if it's really the same line. I don't really care about that. I want to know what the answer is. What would the answer be to this system of equations? Many, or even better would be infinite solutions, yeah.
Just this one.
Infinite solutions, yeah. To be honest, the real answer to this would be all, I think I've said this before, all points on y equals 4x plus 2. I said this before because the answer is always where they meet. And if they are one on top of the other, where do they meet? All the points on that line. And of course, how many points are on the line? Infinitely many, yeah.
So when a mathematician says grand, I mean infinite.
When it says what?
When he says something is, when something's grand.
Grand? No, we don't mean infinite. Grand is not infinite. Yeah.
I don't mean like grand, I mean like
I know what you
grand
mean.
spectrum.
Oh, the grand scale of things.
Yeah.
That kind of
I
thing.
mean infinite.
Sort of, yeah. Okay, I like it. All right. So I want to do a couple examples. We already did a lot of the word problems out of the word problem sections. We're going to do a few more of them. And then we're going to do that last section and be done with it. Let me see if I can find it again. Go there. Go to that place. Okay. Let's try it. Let's start it. Wow. There I am. Yay. Here we go. Let's do this one. That looks nice and gross. Huh? You wait until I get one and then you tell me no? I love it. Oh, well, okay, sure. Which one is that? 5.8 more. What section is that? Wait, I don't know what 5.8 more. Why? Let's see. We'll do that one next. I'm gonna focus this. So let's see. Sashina, exactly. It's not just Meg and Bob anymore. Sashina is a lab assistant at her community college. She needs to make 200 milliliters of a 40% solution of sulfuric acid for a lab experiment. She doesn't have to do some kind of Breaking Bad thing. Oh, God. If you don't know what I'm talking about, it's probably better. So, the lab has only 25% and 50% solutions. How much should she mix of the 25 and the 50 to make the 40? Holy shit. So let's look at it. Let's look at this at what we call like from a higher level. If I have a 50% acid solution and I pour into it some 25%, what am I effectively doing? Diluting it. So as I pour in the lower percentage solution, isn't the percentage going down, down, down? So really, a way to look at this question is, if I start with a 50%, how much of that and the 25 do I put together so that they agree at 40%? So it dilutes it down to 40%. Huh? Oh, no. So it's the jugs? No, it's not the jugs, no. Don't worry about it. It's not like that. No. And there's nothing's going to blow up if we get this wrong. Thank God. All right. Not that I know of.
But Die Hard's a good movie.
It is a good movie. First couple, maybe. All right. So let's see. What is it that I don't know? Start there. If you don't know what the hell to do, start there. And how do you figure out what you don't know?
How much?
Look at the question. How much of the 25 and the 50? Right?
Yeah.
So what do I want to call this? I got a 25% solution, and I got a 50% solution. This would be the number of milliliters of each. So what do you want to call those? I think my red one is the only one that's really working. All right, we'll do X and Y just for tradition's sake, right? Almost always there's going to be a simple equation to set up. Can you guys see the simple equation, meaning it's just going to be x plus y? Yeah, is equal to 200. So almost always, I'm not going to say always because that's, but almost always there's a total equation. If I add the two things I don't know together, I get a total amount. Now, what did I tell you? Okay. Yeah, that's not going to work. Now I've got to bring in what information? I've got 25% solution and a 50% solution. Right? And I want to make a total of 40%. 40% of what? What's the total got to have? 40% of 200 milliliters. Okay, I like it. So we've done stuff like this before where you had to make sure that this plus this equaled that. The units were the same. So tell me this. We got X of the 25% solution. So how much of that is pure acid? 0.25 of it. So 0.25 of this, keep going, plus
0.5.
half of this has to equal the amount of acid total in the solute at the end, which is supposed to be 40% of 200,
Yeah.
which is what X plus Y is. All right, let me stop there for a second. Sometimes I like to make a problem like this dealing with chocolate milk so we don't have to worry about acid. So you can imagine actually doing this without, oh, I spilled it on myself. Shit. So it's milk, so it's better. So a certain percentage of your milk is chocolate, right? You put the chocolate in. You with me? You guys, what's up? Did I say that really weird? I'm sorry.
No, it's just SpongeBob.
I'm no, huh?
SpongeBob.
Is it SpongeBob thing?
Yeah.
I didn't even know.
Chocolate.
Man, I haven't watched SpongeBob in forever. So a certain percentage of your milk is chocolate, right? So this equation is all about, well, let's just stick with the acid, right? That's the total acid. 40% of your end result has to be acid. So I really want this to make sense. Where did all that acid come from? It came from the acid in this guy plus the acid in that guy.
That would be equal.
So that's why that equation makes sense. So the amount of each has to be 200 total. And then a quarter of this is how much acid that has, plus half of that is how much acid that has to be how much acid is in at the end. We've actually done problems like this before, but instead of percentages, we had money amounts. Remember in mixing nuts and raisins and stuff? Same idea, believe it or not. But now, what do? What's 0.4 times 200?
80.
Yeah, move that over once, move it back once. 4 times 20 is 80. And you're like, yeah, what? 25x plus 0.5y. What can you do with this equation if you wanted to, if you don't like decimals? 100, I like it. So move everything by 2. 1, 2, 1, 2, 1, 2. So I can make the second equation, we've got 25x plus 50y equals 8,000. Let me stop for a second. You don't have to do that if you want to, but you can. I want to point out one little thing. Do you notice if I multiply everything by 4, all the decimals are gone?
Yeah.
Because what's 25%? That's 1/4.
Fourth.
And that would make all my numbers smaller, right? Anyway, there's a lot. And do you guys see, can I divide all these by 25 if you wanted to? All right, let's say we didn't notice that. How could I use these two now to solve? Yeah, sure. So how do you solve this one?
Y equals 200 minus 10.
So I know this. And so I can rewrite this as
2 minus
200 minus x. Yeah, okay. And then keep going. These, hopefully you see, and I know these are always weirder, these percentage problems. I know they're a little weirder, but they definitely set up easier than what the word problems we were doing earlier this semester. Is my hope. You'll agree with me eventually. So now if I finish this out, let's see, 25x plus 10, 0, 0, 0, 10,000?
Oh, yeah.
I think that's what that is. So then I get negative 25x. Subtract 10,000, I get negative 2,000. And then I get x equals 8. 80? Maybe it's 80. Yeah, thank you. So then what's y? 80 what, by the way? Milliliters. Yes. Today's a good talking day for me. Too bad I got a meeting to run next. Yay, it's going to be exciting. 200, and then I get y, 200 minus 80. There you go, buddy. 120 milliliters of what? What happened here? You got all mixed up with something. 50%, because that's y. And then this was of the 25% solution. Okay. Yeah. Okay, we got the Morse code class next door. Okay, that was yummy. Let's look at that one. Can you tell me what they say? Or actually, let me see. They've got. Okay. 155 feet. So it goes twice. All right, I forgot everything I just said. So this is a really classic problem. There's a house here. And I want to put some rectangular enclosure there. So one wall is of the house. So if I'm putting fencing up, I don't have to worry about the side, obviously, because it's up against the house. Okay, I like it. So they tell me I've got 155 feet of fencing. 155 feet of fencing. And they tell me, man, today's interesting. Oh, dude. All right. So the way I drew it has nothing to do with anything. I don't have a freaking clue what side. So I could have been like this, right? But I wouldn't normally draw that. You with me? I really want you to understand. When I draw this, that doesn't mean I somehow know that this is longer than that. I'm just drawing an example rectangle. So when I label these, it could end up that this side is longer than that side. Does that mean I was wrong? No. I don't have a clue going into this which side should be longer, right? You guys understand? All right. So it's 155 feet of fencing, and they also say that the length is 10 feet less than twice the width. Oh man, do I have any 10 feet less than twice the width? All right, so what do you want to use for your variables?
L and W.
No way. Just call this one L and this one W and this one W. Is that cool? So there's a total equation. What must be true about W plus L plus W? 155. I mean, right? You can turn it back around. I got all the information. You can turn it back around, Shane. And then that one I can just do directly. The length is 10 feet less than twice the width. So the length is,
W minus 10.
yes, 2W minus 10. We still have people that are putting that backwards and they're getting negative side lengths. That's weird. Creating black holes everywhere. That's bad, I'm quiet. Now what does it look like this is set up for? Yes, substitution. So that's as far as I'm going to go.
Can I say we're 2L and 1 W?
Totally. Well, wait. Oh, if you call this W and this L, right? What did you call these? Did you call these L's
Yeah.
and this W?
Yeah.
Beautiful. Because, right, I really want this to make sense. Why did I call it W? Because I wanted to. Will it really change anything if I call that A? If I call that L and call that W? No. The work will come out the same. Your L will be my W. I like it. Sorry. Sounds like a line from a really weird math romantic. Your L is my W.
The only thing that matters is that two different variables can't add to each other. Like you can't have a W or a, you can't add a W or a W.
Oh, I see. You can't put them together.
Yeah.
Yeah. You can add them together and they could equal something, but you can't combine those symbols.
Yeah.
Yeah. All right. Okay. So the last section. The last section will be relatively simple. What time is it? Oh, geez. All right. Are you working today? A little bit, yeah. Let's first remember, do you guys remember how to do this? Graph a solution to y greater than 3/4 x minus 1. Does that sound familiar at all? What did this involve? What kind of line is it going to be?
A dotted,
Dashed
yeah, dash.
or dotted?
Correct.
Right? And how do I graph that line? Yeah, I know the y-intercept is
-1.
0, -1. And I want to go, from there I want to go up 3 over 4. And like you said, it's going to be dashed.
And you said you can also, like, if you wanted to graph more, you just do it backwards down 3 or,
Yeah, totally. If it makes more sense with,
yeah,
you know, like if this is the edge of your paper, you might want to go the other way.
yeah.
Yeah. And then how do I tell? Now that by itself, we should know by now from that one quiz we did or the test or whatever. That's not good enough. The shading is the answer. So how do I tell which side is shade? Yeah, if I plug 0, 0 in, is 0 bigger than 0 minus 1? Is 0 bigger than -1?
Yeah.
So that side must have the answers because it worked. There it is. Must be that side. How would I do it? Bigger, up, done. Okay, maybe. So that's old news, right? I mean, I like that. Math needs some musical interludes. So, the only new thing in this last section, it shouldn't be a big surprise, because what's the new thing in this whole chapter? We don't just get one line, we get two. So the new thing, and in fact, when we first learned this, I told you this was going to happen. They're not going to do one inequality, they're going to do two inequalities. And what do? Just graph them on top of each other. So take a minute and do this. Graph this guy. I'll be nice on this guy. And then graph this guy right on top of the other guy. They don't care. What you got, Jeff? Just do something. There it is, buddy. All right. So what I always tell people is finish this all the way out on a graph. Shade it and everything. And then draw this one on the same graph. Because the answer will be where the shadings overlap. Oh, shit. while you guys are doing that, I'm gonna give you the practice test. Practice test. People that left don't want one, it's okay. Goodness.
Yay.
It is only one side of a notice number 7 has all the word problems in it.
Yay.
All right, let me catch up to you. This first one, what's the y-intercept? 0, 4, 11. And then from there I go down 3, 1, 2, 3, over 4. If I went back 4, that would mean that 4 should be negative, which means the whole thing should be positive because the negatives would kill each other. So you either go down and over or you go up and back. You can't do both if it's a negative slope. And how am I going to make this line? It's going to be, yeah, solid. I see a line, I'm going to make a line. Oh shit. Yeah, all right. Perfectly straight. And then how do I tell which way to shade?
0.
Yeah, if you put 0 less than 0 plus 4, is 0 smaller than 4?
Yes.
Yes, that's crazy. Or just, down. This guy, what's his y-intercept? 0, negative 1? Of 3, 1, 2, 3. Over 1? What kind of line? So this little arrow's got to get out of here. No, Jeff. That's the dash it thing. There you go, buddy.